Welcome back, ladies and gentlemen, to Calculus C3-3. And it's obviously a beautiful day for math because making a video about 3 new derivative rules for you. The first one we've been talking about and using already pretty extensively, the power rule. But I'm going to add 2 more to your repertoire. And this entire chapter now, from kind of here on out, we're going to be learning a bunch of derivative rules. And unfortunately, that kind of means a lot of memorization. However, these first 2, arguably, there's not much to memorize here. And I'll explain why in just a moment. So obviously a beautiful day for math. I forgot to mention that on C3-2. So definitely want to point it out today on C3-3. And as we can see, 3 new rules to add to our toolbox. There's no doubt in my mind, it's a beautiful day for math. So this first one, we've already been talking about this. It's the power rule. We investigated that in C3-1. No glue in there needed since that's something that you guys can discover on your own. The power rule, it's amazingly beautiful. And we see that if we're taking the derivative of x to the nth power, it turns out the exponent of n drops down in front of the x and becomes the coefficient, and then we subtract 1 from that exponent, so it's n minus 1 now. So amazingly beautiful. So let's look at an example that kind of shows what's going on there. So on this first one, it's important to see there are some hidden tricks in this one. So I'm going to rewrite this beast. It is actually y equals x to the 5th plus 2x to the 3rd minus 5x squared. So there's nothing different there. It's these last 2 terms that are kind of written in a different way, and just immediately looking at that, we wouldn't know how to apply the power rule. However, right now we have the 4th root of x, which actually means it's x to the 1/4 power. The 4th root of x is actually the 1/4 power. It's the exponent of 1/4. This is kind of just like made up notation right here. This root notation. It actually means the 1/4 power. And similarly, we have 1 over x squared. Just looking at that, it might not seem obvious how we would apply the power rule. But it's 1 over x squared, which we have to remember is actually x to the -2nd power. So if it's downstairs in the denominator, we shift it upstairs, and then the exponent becomes opposite. In this case, it becomes negative. So if we apply the derivative, if we take the derivative here, we can apply the power rule. So the 5 is the exponent, so that means that plops down and becomes the coefficient in front of the x. So it's 5x, and then the power rule says we subtract 1 from the exponent. Amazingly beautiful. Can you believe that? And you discover that in C3-1 in the exploration activity there. So 2x to the 3rd power, the 3 drops down and multiplies with the coefficient that's already there. 3 times 2 is 6. So in this first one, there's kind of an invisible 1 here. 5 times 1 is 5. So in this case, 3 times 2 is 6, x, and then we subtract 1 from the exponent. So it's the 2nd power now. Going a little faster now. So 2 is the exponent here. That 2 drops down and multiplies with a -5, so it's -10x. And then subtract 1 from the exponent, which means there'd be a power of 1 there. But no need to write that, because we're lazy. And then we have x to the 1/4 power. So that 1/4 drops down and becomes the coefficient in front of the x. And then we subtract 1 from 3/4. Or excuse me, whoa, there, gave it away. Subtract 1 from 1/4. So we subtract 4/4. So 1 minus 4/4 becomes -3/4. And then -2 is the exponent here, so that plops down. And now that becomes -2x, and then subtract 1 from that, -3. So there's the power rule. We'll just leave it like that. And there is the derivative there. Not too shabby there. That's something we've already been talking about. So the next one is going to be new to y'all. So this is if we have the derivative of a product. And in the warm-up, we had this exact same problem, and one option is to distribute this, is to multiply these two binomials and get something in its standard form. However, sometimes that's not an option. So in this case, we could distribute this and use the power rule and then we're golden. But sometimes we might have nasty equations inside these parentheses, or nasty equations that we're multiplying together, and the product rule is necessary. So let's see what we got here. We have the derivative of u times v. So we're representing two things being multiplied together by these variables u and v. And it looks like the product rule says we keep the u the same, and then we multiply by the derivative of v. So keep the first thing the same, keep the u the same, and then take the derivative of v. And then we add it to the v, so the second thing, so leave the second thing alone, times it by the derivative of the first. So that's why I kind of say there's nothing to memorize here, because it's just leave the first thing alone, take the derivative of the second. Leave the second thing alone, take the derivative of the first. So you're kind of just doing the derivative on both of them, and there's really nothing to memorize here because 2 plus 3 is the same as 3 plus 2. So it doesn't really matter which order you put them in. So here's our problem right here. We have y equals, okay, we're going to take the derivative of this. So it's important to notice that in this case, the u is that first parenthesis, and the v is that second. So u times v. So we want to take the derivative of that. That's what the left side of this equation is. So the rule says we leave the u alone. So we can start taking the derivative. And I'm going to do it down here. dy dx. So it says leave the u alone. So u is x squared plus 4. And then times it by the derivative of v. So for this first step, I'm not actually going to apply the derivative. I'm just going to indicate with my notation that we're going to take the derivative. So leave the u alone, and then we're going to take the derivative of the second. And then plus, leave the second thing alone, the 3x plus 1. Leave the v alone, and then multiply by the derivative of the first thing, which is x squared plus 4. Alright, so I've actually done no calculus here. I've just indicated that I'm about to do some calculus. So let's continue and actually do some calculus. So we leave the first thing alone, so that'll be x squared plus 4. And then we're going to take the derivative of 3x plus 1. So the derivative of 3x is 3. And then the derivative of 1 is 0, so that's good. That's done. And then leave the 3x alone. And then take the derivative of x squared plus 4. So the derivative of x squared is 2x. The 2 drops down. And then subtract 1, 2x. And then derivative of 4 is 0. So that's done. And arguably that is done right there. That is the derivative. But just to prove that it matches the derivative of these two things multiplied together, if you weren't here for the warm-up, you should do that and multiply these together and use the power rule on the standard form that results and see that it matches what we're about to get here. So 3 times x squared, 3x squared plus 12, and then do some distributing over here, 6x squared plus 2x. So if we simplify that all up, dy dx equals, so let's see, we would have 9x squared plus 2x plus 12. And if you distribute that original problem right there, find the standard form, and then use the power rule, it should match this beast right here. So that's the product rule. So again, arguably nothing to memorize there. Leave the first thing alone, take the derivative of the second, plus leave the second thing alone, take the derivative of the first, and then simplify. So the next one is the quotient rule. And I can summarize the quotient rule in, I don't know, a quick phrase. Low-D high. Low-D high. So you hopefully already know what this means. Low-D high. So the derivative of a quotient. So we're taking the derivative of a fraction. We have u over v. So this is a fancy way of saying this is a quotient. That's a fancy way of saying fraction. So the derivative of that is low-D high. So the low thing, which is the v, so we leave that alone, low, and then d high. So the derivative of the high thing, the thing up top in the fraction, the numerator. So low d high minus high, the high thing, the thing up in the numerator of the fraction, high d low, all over low squared. And we'll notice it's kind of similar to the product rule in that we leave one thing alone, take the derivative of the other, etc., etc. But in this case, there's a subtraction sign, which means the order does matter. So that's why I always start saying low d high, and then arguably you can memorize the rest because it's minus and then vice versa. You flip-flop what you're taking the derivative of and leaving the same. And then all over low squared. So hopefully this one will kind of become a natural memorization. There's nothing really to kind of drill into the brain. But let's apply this quotient rule. So in this case, it's important to notice that the u is the numerator, so u, that's the high, and then the v is the denominator, that's the low. So high and low. All right, so if we're going to find the derivative, let's see, how can I squeeze this in? So low d high, so I'm going to leave the first thing alone, so dy dx. So low is the 3x plus 1. And then low d high. So I'm going to take the derivative then of the high thing. So derivative of x squared plus 4 dx. And similar to the product rule, I'm not going to do any calculus yet. I'm going to indicate that I'm about to take some calculus, or I'm about to do some calculus. So low d high minus, and then the high thing, which is x squared plus 4. Let's see if I can squeeze this in. High d low, and then the low is 3x plus 1. So the derivative of 3x plus 1, just barely squeeze it in there, all over low squared, which is 3x plus 1. So I've done no calculus yet, so low d high minus high d low all over low squared. Low d high! So I continue. Dy dx, so 3x plus 1. And now I'm actually going to do some calculus. So the derivative of x squared plus 4, we've already done this, x squared plus 4, high d low, so the derivative of the low thing is 3x plus 1, so the derivative of that is 3, all over low squared. So that is the derivative of that nasty quotient right there. So I'm going to leave it at that. And depending on the situation, you want to simplify. On a free response problem, that's done. We've taken the derivative. There you go. There's the derivative. If you're doing a multiple choice test and you're trying to find the correct answer, you need to be comfortable with simplifying that. And then when answering these textbook problems, the answer in the back of the book is usually simplified in some way, so you should be comfortable in trying to find that answer. It's a challenge. Find that simplified answer. But for now, that is the derivative using the quotient rule. All right, enjoy.